The next thing we're going to learn in conjunction with our Lewis dots are how to draw polyatomic ions. Now these are ions just like before where we need brackets and the charge outside, but poly means many, and this is a group of covalently bonded atoms with a charge. And what's important to note is they always stay together. So you saw a video where things dissolve in water and they break apart into atoms when they're ions or ionic compounds. This is just one ion, so it stays together as a whole group even when you put it in water. Okay, so the other thing is you need to add and subtract electrons for the charge. So here's 2 minus. That means 2 electrons were added. So when I add up my electrons that come to the party, carbon brings 4, 3 oxygens each brings 6, and then that 2 minus charge means I'm going to add 2 extra electrons, so I have 24 valence electrons. So here's my carbon, my 3 oxygens. I have all 24, and let's just redo this so you could see what would happen. That would be 24, and then my carbon would not have its octet there. So this is where I have to go and share a pair. So now I'm going to share my pair, and now carbon has its octet. So that's what I mean by sharing a pair. Okay? Now, when we have this carbonate, we need to talk about resonance. Resonance is when you can draw 2 or more valid Lewis structures, and then we're going to talk about the bond order or the average length of all of them after we look at that. So again, here's how I calculate all my electrons that come to the party. And you saw that I wrote my double bond on the left side here, but I could have written it on the right side or I could have written it on top. And when I was in high school, I said, well, why does it matter? You just spin it and wherever it goes, it goes. Well, the reason that it matters is because not one of these actually exists in nature. And that's what these arrows are here for. So when you write resonance, you have to write that double-headed arrow. Arrows are very important in chemistry. Different arrows mean different things. And it means that there's an average of these 3 structures. Okay, so no resonance structure exists in nature. It's an average of all 3 of the structures. So I have a double bond, a single bond, and a single bond. Double, single, single, double, single, single. When I take that and average it, so I have 1 plus 1 plus 2 divided by 3, I get a bond length of 1.33. So in actuality, when they measure these bond lengths, there isn't a single bond, and a double bond. There is 1 1/3 bond between all of them. And when we have a single bond, it doesn't pull the oxygen as close as the double bond. So if this was true, these 2 oxygens would be farther away than this oxygen bonded with a double bond. And just so you know, if you had a triple bond, that would make that bond length even shorter. But when they measure it, there is not a double, single, single. There's a 1.3 bond length between everything, and that is also called a bond order. A bond order of 1.33 means I have about 1 1/3 bonds. So the electrons are actually kind of spinning around here, and they're all sharing and they're all bonding, and it's really just an average of all that.